Here we're going to work through the solution of the third exercise in the depreciation self-correcting exercise set, which is a part of our plant and machinery module. In this exercise, by the way, it's an extension exercise, so you do it if you're interested in this topic and you have the time. It's not core, so you don't absolutely need to do it. However, I do recommend that, if possible, have a go at it because it gives you a very useful skill. Here we're going to be looking at developing an understanding of what depreciation to use and therefore value an asset based on the depreciation evidence that comes from comparable sales in the market. So it's a comparable sales kind of exercise, but we're using comparable sales evidence to give us depreciation. Now, some of you might say, well, hey, that's exactly what we do in the cost approach for valuing houses and things like that. And you're exactly right. Here it's a little bit more stylized. If you work through this exercise, you may find that that cost approach stuff may make a little bit more sense to you. Let's see how we go. We're going to begin by filling in the easy bits. The easy bits here is we've got a asset that we're looking at. We want to work out its age. We've got a valuation date and we've got a purchase date, so we can work out the age at present, and that's going to be using what should be now a very familiar equation. That's the valuation date less the purchase date, close brackets, divided by 365. That gives us 6.5 years. We also have some comparable sales. Now we want to look at the age of these comparable sales at the time they were sold. Similar equation. We're going to look at the sale date. Need to put a bracket in there to begin with. Minus the purchase date, date new, date when it was new, and divide that by 365. By the way, when you're working with asset registers, just about every organisation has different names for the different columns, and so you have to be able to interpret what jargon, what terminology they're using. I cannot even attempt to give you all of the different names that might be used for any one of these different columns, but usually a bit of common sense will reveal what's going on. Okay, we've got the age therefore, and we work that out, and so this first one is 8.87. We're going to fill that down. Now here the borders have filled down and messed up my spreadsheet, but we'll just work with the borders. The yellow highlights have gone out, which is exactly what I do want to see, which tells me that I've got the right mathematics. That's nice. So they're the ages of the comparable sales. The other thing we can work out with the comparable sales is what depreciation to new those sales had. So let's look at how we work that out. We've got, let's look at the hint first of all. It's a proportion that the sale price was of the current new price. So that really tells us all. And remember, there are a number of ways of doing this, depending on what the exercise is, what information you have. In this exercise, we're going to use the proportion against the current new price. That should be fairly easy because we look at the current, we have the sale price. The first one is 228,000. We're going to divide that by the current new price. That gives us a depreciation to new, which is 49%. Again, we're going to fill that down. And now we've got a nice little set of depreciations, and we've got a set of ages. Now you'll notice on this I have already formatted up a graph, what Excel likes to call a chart, and that simply graphs the ages of the different sales and their depreciation amounts, and that will give us an idea of the trends in depreciation that we're looking at. And remember, understanding those trends is very, very important. Now we can look at our subject. Our subject property, I'm going to simply import its age. We calculated it over there, and I'll put it in yonder. And what have we got? We've got 6.5 years old, 6.6 years old, close enough too. We look at our chart here, we can eyeball that in, and we can say, well, let's say about 55%, something like that, 55 or 60. And so already we can estimate our depreciation simply off our market data. Let's try putting that in. Let's say 60%. Now you'll notice here that this particular model, I've put some hints in for you. So I said, yes, you could use 60%, and I'm saying that's close, you could do better. Let's try 55%. Oops, looks like we're getting the same result. So somewhere between 55 and 50 and 60. So we'll try 58. Oh, and the comment, the criticism, has gone away, and so we'll adopt 58. Down here, we'll put that in. We'll simply bring it down as well. We don't really need to do that, but I'm putting in these two bits of data here for the subject simply so we can locate our subject property within the comparables. So it's just a nice way of me seeing that the number is reasonable. I'll just change a number here. I'll make it 70%, let's say. And you see how it moves it out? And you can see it's visibly outside of that trend. So I can say that's high. Well, my self-correcting machinery is telling me that it's wrong anyway. But you see, when I'm in the field and I don't have small self-correcting exercise to work with, tell me what the answer really should be. I just have to eyeball it from the graph. There are mathematical and statistical ways of doing it. Very few people I'm aware of use them unless they're built into packages that they've either built or bought. But a lot of valuers use something like a visual check there, and that's quite sufficient considering the precision that we're working to. So I'll come back and put that back in. Okay, from that, now we've got a depreciation adopted for our subject asset, which is consistent with the market, and we simply work out the fair market value as being the replacement cost new times the adopted depreciation. Bingo, job's done. Now, I'm also expecting here that you do one more little bit of finesse to the exercise. We've got $211,120 worth of asset there. However, is that reasonable? Well, I don't know if we're really that precise. I'm suggesting that you use the Excel round function to bring that down to the nearest $1,000. Now, the round function, usually we use that to specify how many decimal places we want to put in, and so usually we put in a comma in the second parameter, which might be 3, to say 3 decimal places, and that'll give us 3 decimal places. We don't want 3 decimal places, we want to the nearest 1,000. And so instead of taking numbers to the right of the decimal place with that 3, we're going to be taking numbers to the left of the decimal place by using a negative number there. And so using the Excel round function, but with a negative second parameter, in this case -3, -3, what that will do is round my number to the nearest $1,000, which is a nice tidy way of putting into my model a automatic way of rounding to something reasonable. And in fact, I could probably even round it to the nearest $10,000, and that would be pretty reasonable as well, because realistically, valuations aren't done to 1% precision. So here we are with $211,000 as a result. Job done.